Welcome to this explainer. Today, we're diving into something truly mind-bending, foundational substrate theory. We're going to unpack a brilliant parameter-free framework that literally resolves some of the biggest, most stubborn mysteries in modern physics. I'm honestly super excited to share this with you because we're looking at a theory that derives the most complex phenomena in the universe from just 8 fundamental inputs. We're talking things like the speed of light, Planck's constant, just basic constants. And the crazy part? There are 0 free parameters here. No hidden dials to tweak, no fudging the math to make things work out. Finding a completely parameter-free theory in physics is astonishingly rare, yet this one elegantly answers questions that have completely paralyzed astrophysics for decades.
So, here is our roadmap for today. We'll be fixing broken physics, looking at the 4 axioms of FST, resolving the singularity, talking about time and information, and finally, exploring galactic dark matter engines.
All right, part 1, fixing broken physics. Let's get right into it.
So what actually happens when our absolute best theories of the universe just break? Well, for nearly a century now, classical physics has hit this massive, impenetrable brick wall whenever it tries to deal with the most extreme environments in the cosmos. It's a real crisis. We have these 2 incredibly successful frameworks, right? General relativity, which works beautifully for massive things like stars and galaxies, and quantum mechanics, which is perfect for the tiny subatomic world. But when we try to mash them together inside a cosmic pressure cooker, like a black hole, the whole mathematical framework literally shatters. The equations start spitting out infinities. And in physics, an infinity is basically a giant neon sign screaming, "Hey, your theory is fundamentally incomplete."
Specifically, this breakdown forces us to wrestle with 3 massive, deeply interconnected headaches. First up is the singularity problem. General relativity predicts that at the absolute center of a black hole, matter is crushed into a literal point of infinite density, which, let's be real, is physically impossible. Second, the information paradox. If a black hole evaporates over trillions of years, current theories suggest all its quantum data is just lost forever. That's like deleting the universe's hard drive, and it completely violates the core laws of quantum mechanics. And third, the dark matter mystery. Roughly 85% of the universe's mass is totally invisible, holding galaxies together, yet decades of exhaustive, multi-billion-dollar searches have found absolutely nothing. Moving right along to part 2, the 4 axioms of FST.
To escape this physics crisis, foundational substrate theory, or FST for short, shifts our entire paradigm. Instead of treating space-time matter and gravity as these separate, isolated things, FST suggests they all emerge dynamically from a single, continuous foundational field. Think of this substrate kind of like an infinite, incredibly deep ocean. The particles, forces, and planets we see around us, they aren't separate objects floating in the water. They're actually the ripples, waves, and geometric distortions of the water itself. Everything is just the geometry and dynamics of this one underlying substrate in action.
And this elegant theory is built firmly on just 4 foundational axioms. You don't need any extra justification for them. Axioms 1 and 2 just establish that the field is continuous and fix its phase velocity right at the speed of light. Simple enough. But the real game-changing insight hits us in axioms 3 and 4. The law of 0 pairs our everyday standard matter, you, me, the Earth, with a negative mass counterpart called complementary matter. They perfectly cancel each other out, meaning the total net energy of the universe is exactly 0. Following that, geometric reciprocity inextricably links their movements together, almost like 2 perfectly synchronized answers.
And here is the exact mathematical heartbeat of that geometric reciprocity. The velocity of standard matter, which we call v sub p, and its invisible complementary matter shadow, v sub c, are inversely linked. Their product always equals the speed of light squared, c squared. This mechanic is absolutely vital. It means if standard matter slows down to a near halt, its invisible complementary matter counterpart has to accelerate to incredibly high speeds, spreading out into this massive diffuse halo. Keep this inverse relationship locked in your mind, because we're going to use it to solve the entire dark matter mystery in just a few minutes.
Okay, part 3, resolving the singularity. When you put the old classical physics side by side with FST, it's a stunning mathematical triumph. Instead of matter hopelessly collapsing into an infinitely dense point, FST actually uses the universe's natural constraints to prevent a singularity from ever forming in the first place. The physical crush literally caps out. FST replaces that impossible singularity with a highly compressed, but very much finite, Planck scale core.
So look at this equation right here. Rho core equals rho 0 times the hyperbolic cotangent of a to c. The crucial takeaway is that the central density remains strictly finite, specifically because of the continuous cosmic motion of the system. FST uses a kinematic variable called rapidity, that's the Greek letter eta right there, which is just a specialized way to measure cosmic motion. Because absolutely nothing in the entire universe ever sets perfectly, flawlessly still, this rapidity parameter is never exactly zero. And that tiny, non-zero motion acts like a mathematical shield, preventing the density from shooting to infinity. For a standard black hole, the density peaks at a massive, but finite, 2.14 times 10 to the 107 kilograms per cubic meter. Boom, singularity resolved.
Section 4, Time and Information. Because things get even weirder inside that core.
So the physical crush is solved, but what happens to time and data? Well, the core is actually this highly structured two-layer system. You can think of the primary layer almost like the physical hardware of a hard drive. It handles all that immense kinematic compression we just talked about. Beneath that is the secondary layer, acting like the software data protection. Through hyperbolic coupling, it manages the deep underlying informational architecture of the universe, stepping right up to tackle the infamous information paradox.
And the time dilation here is literally mind-bending. According to FST's hyperbolic kinematics, time behaves in completely contrasting ways depending on where you're standing. If you're an outside observer looking at the edge of the black hole, the event horizon, time literally freezes. It just stops. But deep inside that finite core, time stretches infinitely. It's a total symmetric inversion of how we normally perceive time flowing. This extreme time divergence is driven by what's called the multiplicative informational balance. T sub m times T sub cm equals T0 squared. Just like we saw those velocities inversely mirroring each other earlier, time does the exact same thing. This principle guarantees that the fundamental variables of time between standard and complementary matter always multiply out to a constant. So that insane stretching of time for standard matter inside the core is perfectly counterbalanced by the complementary matter field. It maintains absolute cosmic symmetry. Which leads us directly to the resolution of the information paradox, holographic information conservation. Think of it like shining a highly detailed beam of light through a dense cloud of sparkling dust. The light transfers its exact imprint, its information, onto the dust without actually destroying its original energy. The data is just perfectly preserved in a new medium. In FST, as standard matter collapses, its quantum state is perfectly imprinted onto the complementary matter field. The universe's hard drive is totally safe, keeping the rules of quantum mechanics intact even as the black hole evaporates over eons.
Finally, Part 5, Galactic Dark Matter Engines. Let's zoom way out. We are jumping to the cosmic scale now for a massive paradigm shift. Remember that inverse velocity equation, VC times VP? Well, a supermassive black hole sits at the center of a galaxy, nearly stationary, meaning its standard matter velocity is almost zero. As a direct mathematical result, its coupled complementary matter has to shoot outward at immense velocities. This generates a massive, diffuse, invisible halo. Astrophysicists have spent decades looking for a mysterious dark matter particle. But FST's unified generation model basically proves that dark matter is just the invisible shadow, the complementary matter exhaust generated by the core of a supermassive black hole.
And the proof is in the pudding. Looking at the empirical data, FST's unified generation model predicts the exact dark matter fractions of these galaxies with over 97% accuracy. And remember, that is with absolutely zero free parameters. Hitting 97% accuracy across entirely different types of galaxies without fudging any numbers is practically unheard of in modern physics. Look at the Milky Way. Observed dark matter fraction of 6.0, FST predicts 5.87. M87 is 2.0 observed, 1.94 predicted. And Draco, a super-dense dwarf galaxy, is 100 observed and 102.3 predicted. It's all just determined by the density and age of the central engine generating that complementary matter. It perfectly fits. So it leaves us with this really profound realization about our universe. Foundational substrate theory shows us a cosmos where literally everything is paired, perfectly balanced, and completely intertwined. Singularities are smoothed out into dense physical cores, lost quantum information is safely recorded in an invisible shadow, and that very shadow is exactly what holds our galactic homes together. So I'll leave you with this to ponder. If the missing pieces of our universe were never actually missing, but just the literal inverse of our own reality, what other hidden symmetries are out there, just waiting for us to discover them? Thanks for exploring this with me today. Keep asking those big questions.